go with that. So Newton's first law here. Oops, first law. Okay, so Newton's first law is not an equation, but does require a little diagram. So this is all about resultant forces. All of Newton's laws about resultant force. So look at Newton's laws is the situation when we have zero resultant force. So this here, as you can plainly see in the moment, is a super duper lovely car. Okay, and this is another one beside. We're looking at two situations of an object. So an object when it's stationary, I'm picking the object here being a car, and an object when it is moving. Okay, so if an object is moving, it will have a contact force opposite the weight force, which I'll just label W. It will have a thrust force for the engine pushing forward, and it will have a drag force from the air resistance. If the object is stationary, it will just have the contact force from the ground, and it will have the weight acting downwards. Okay, so those are the two situations we can have. So if we've got a zero resultant force, so zero resultant force, which we have in both those situations because the weight is cancelled by the contact force, the drag is cancelled by the thrust force when it's moving, and here when it's not moving, we've got the contact force is cancelled by the weight. So in those situations, what happens is the object is either stationary or moving at constant velocity. So stationary or constant velocity. Okay, now velocity, not speed. That's important. Speed is not in a straight line here, because velocity changes with a resultant force, because forces will change direction as well. So Newton's first law basically says when we have zero resultant force, we have the object is either stationary or it's moving at constant velocity. And that's it. Okay, and if we have a resultant force, however, this is the case with Newton's second law. So Newton's second law is what happens with a resultant force. Newton's first law is what happens when there is no resultant force. So in this case, again, we've got our car, and in this situation, we have the car accelerating. So again, if I draw my car, it doesn't have to be a car, it can be any object you want. Okay, my beautiful A-level art. So there is the thrust force forward. The drag force is smaller. So notice the thrust force is large. The drag force is small. So we've got a net force going forward. So this one is now, there's my little faster stripes. This one's now flying through the air. It's accelerating. Excuse me. It's accelerating. So what we have then is an equation to go with this one. Force is equal to mass times acceleration. Okay, that's one of the equations you need to know. And the result of this then, the resultant force is, so we have a resultant force because add those two together, we still got a force. And that means we will have acceleration. And that is Newton's second law. Okay, that leads us on to Newton's third law. And this one doesn't have an equation. It's only the second law which has an equation. So, but Newton's third law, this one is what happens then when we have two objects pushing against each other or two objects interacting. So whenever there's two objects interact, so whenever two objects interact, so that's you pushing against the wall, kicking a football, an apple landing on your head, then what happens then? The forces are equal and opposite. equal and opposite. And that is Newton's 3 laws. Ta-da! Okay, and that is all you need for those 3 laws. So basically, the first law is zero resultant force. Objects are stationary or constant velocity. If there is a resultant force, the object must be accelerating. That also means slowing down, because acceleration means speeding up or slowing down. So basically, change in speed. And if 2 objects interact, their forces are going to be equal and opposite. Okay, this section then is called next section is inertia, which is basically just for higher tier. Okay, to go with this one, but it goes with each of the laws. So for this one, inertia, what actually is it? It is the tendency to continue at rest or motion. So the tendency to continue at rest or motion. So basically, an object will carry on doing whatever it was doing. So if it was stationary, it remains stationary. If it was moving at constant speed, it remains moving at constant speed. Okay, so it fits in Newton's first law, basically, in that sense. In terms of Newton's second law, there's a link as well, because if we rearrange that equation, we've got mass equals force divided by velocity. And that mass in this case is called inertial mass. Basically, the bigger the mass, the harder it is to move. Okay, so if I have a tiny little mass like that, and there's me pushing it, that's easy. If I've got me pushing it, and it's a huge, big mass like that, that's not going to move at all. Okay, so inertia is what you all experience in the morning when you hear that shout, it's time to get up, your alarm goes off and you don't want to move. The tendency of an object to continue at rest lying in your bed. That is what inertial mass is. And in terms of Newton's third law, to put it in an example of it using Newton's third law, this is a wall. Okay, and you have somebody pushing against the wall with very long arms. Okay, what you've got is the contact force this way. Will exactly equal the pushing force that way. So the 2 forces are equal and opposite. So the wall continues in its state of motion, i.e. not moving. And that is Newton's 3 laws and the explanation that matches with